All right, so 1.6 is named other types of equations because we're just basically looking at different problem-solving techniques where it's not necessarily quadratic, but it's very similar techniques to solving those. So you're going to see cube roots, you're going to see negative exponents, you're going to see fractional exponents, things like that. So first thing we'll do is we'll look at a cube root equation. This is going to be similar to where you're using the square root method. You're just now cube rooting. So in this case here, what I want to do is I want to isolate any of my radical terms. So that would be the first thing that I do is isolate your radical. I'm actually going to write this over on the other side so we can work on this side. Okay, so what I would do is I would start with the minus 11 and I would add it to both sides. Those are going to cancel out. I'm going to have 2 times the cube root of x equals 14, 11 plus 3. And then I'm going to continue isolating. I have 2 times the cube root of x, so I'm going to divide both sides by 2. I'm going to get cube root of x equals 7. Okay, so now what I want to do is I want to undo the cube root. So I'm just going to use opposite operations. Okay, to cancel the radical. Okay, so the opposite of cube root would be to cube. In this case, let's see, cube root cube. So we say opposite operations just because the opposite of square root is squaring. If it were a 4th or a 5th root, you would raise it to that power. So you're raising it basically equal to the index of the power. So I would cube this, and I would also cube on this side. So here the cube root and the cube are going to cancel each other out. You're going to get x equals 7 cubed, which is 343. Okay, and that's going to be it for this one. Okay, so then the next one, yes. Yeah, it's just going to say solve. Now this one you don't need to check because a cube root can come out as a negative on the other side. Okay, so we're going to, I think later on we're going to look at some where you're going to have to check. Okay, you can check this one if you want, but it's not one where you might have an extraneous solution and it's necessary to check. But you can just do check. We're going to go check, but I'm going to put in parentheses optional. All right, so same process for number 2. Okay, this radical term is already isolated. So what I'm going to do is I'm going to start by raising both sides to the 3rd power. So here the cube root and the cube will cancel out, and I have 1 minus 5x equals negative 4 cubed, which is going to be negative 4 times negative 4 times negative 4, and that's going to give me a negative 64. And then I'm going to go through the x needs to be solved for or isolated now. So I'm going to take the 1 and I'm going to subtract it from both sides. That's going to bring me a negative 5x equals negative 65. And then I will divide both sides by negative 5. Negative 5s will cancel. I'm going to get x equals negative 65 divided by negative 5 will give me a positive 13. Okay, and I can look at that and check real quick. 1 minus 5 times 13. 5 times 13 is 65. 1 minus 65 is negative 64. Cube root of negative 64, negative 4. You can take a cube root. You can take an odd root of a negative. That's okay. You can take an odd root of a negative. So if I go cube root negative 64, that's fine. It's just a negative number. But I can't take an even root of a negative because then two negatives would then cancel out. All right, so then this next one, this is just a factoring problem. It just looks a little different because you start with an x to the fourth. Okay, but when you're doing the factoring problem, all you're doing is you're splitting the middle term. So if I have x squared, is that a plus? Yeah. So if I have x squared plus x minus 20, I would factor that with an x and an x. This is the same thing. I'm just factoring it instead with an x squared and an x squared. Okay, because if I did this factoring and I went to multiply it out, I get x times x, x squared. So in this case, when I factor, I just do x squared and x squared. So you're just splitting that middle term. Actually, I'll write it right here as well. So split middle, split middle. And then you're looking, okay, what are factors of negative 20 that are going to add to positive 1? What do we got? 5 and 4. So you've got, let's see, 5 minus 4 or 4 minus 5? Yeah, you've got a positive 5 minus 4. So you get your two factors. It's solving because there's an equals 0. So then you take each factor and set it equal to 0. So you have x squared plus 5 equals 0. X squared minus 4 equals 0. Okay, so here I would subtract a 5 from both sides. I'm going to get x squared equals negative 5. Then I want to take the square root of both sides. So this is going to give me x equals, when I take the square root, do not forget, plus or minus. And then the negative 5, so that's going to be I radical 5. So that's the first one. And then the second one, I'm going to add 4 to both sides. I'm going to get x squared equals 4, and then I'm going to take the square root of 4. So what's the square root of 4? 2, but it's plus or minus 2. Remember, you started with 4, x to the fourth. That's how many answers there's going to be. So there's 4 solutions here. Okay, so anytime you're solving and you take that square root, you got to add that plus or minus in there. So you have 4 solutions. Or you could write it like this. X equals negative 2, positive 2, negative I radical 5, positive I radical 5. All right. You had a question? Okay. Okay. So now this next one, this is actually just a normal solving one. You just have to work it out before you go to solve. So I'm going to make 2 copies because this is x plus 3 squared. So this is going to be x plus 3 times x plus 3 plus 7 times x plus 3 minus 18 equals 0. So we're going to multiply everything out, then combine like terms. So I have here x times x is going to give me x squared. X times 3 will give me a positive 3x. 3 times x will give me a positive 3x. 3 times 3 will give me a positive 9. Then I'm going to have 7 times x, that'll give me a positive 7x. 7 times positive 3 will give me a positive 21. And then bring down that minus 18 and the equal 0. Let's clean up on the left side. So you've got an x squared. You've got the like terms here, 3x plus 3x. And you also have a 7x. So 3 plus 3 is 6, plus 7 is going to give me 13x. And then I have 9 plus 21 is going to give me 30. Minus 18 should give me a positive 12. So now I have a quadratic. And can I factor this one? Yes, I can. This is a nice one. What factors? What multiplies to 12 and adds a 13? Yeah, 12 and 1. So x plus 1, x plus 12. Take each of your factors and set them equal to 0. So you get x plus 1 equals 0, x plus 12 equals 0. Then you would subtract 1, so you would get x equals negative 1 and negative 12. So you started with x squared, you have 2 solutions. And then we have negative exponents again. As promised, I told you guys we'd have another one. Okay. So for the negative exponents, you first want to simplify. So what number is going to be in front of these y's here? Yeah, a 1 and a negative 1. So when I'm simplifying this, I'm going to keep in mind that there's a 1 here, and you have a y to the negative 2. So that's going to drop down as 1 over y squared minus 1 over y to the first, or just y, minus 6, and I'm just going to go ahead and put that over a 1. Okay, so when we have the negative exponents, that means we have fractions. So then when we have fractions, we want to get rid of the fractions, and we want to multiply them out using an LCD. So my LCD in this case, take the largest exponent, so y squared. You have a y to the first already in that y squared, so you just need the y squared. And you don't need the 1. Okay, then multiply each term on the top by y squared. You can do the 0 as well if you'd like. Just so you know that you do multiply everything. Just in case. Yeah, but I would set it equal to 0 first. So these y squareds cancel. You get a 1. Here you have y squared over y, so that's just going to take one of the y's out. So this is going to be minus 1y. And then you're going to have a minus 6y squared. And then 0 times y squared would give you 0. Okay, now it's a quadratic. So I'm going to write it. I'm just going to rearrange it. So this 6y, that's negative. So it's a negative 6y squared minus 1y plus 1 equals 0. So it's a quadratic, so we get to decide how we want to deal with this. We can do the quadratic formula, or we can factor, possibly. I think we can factor this one. We can. You guys want to factor, or do you want to do the quadratic formula? Let's factor. Okay. So if I'm factoring this, and let's go ahead and we'll do the AC method, because I know some of you guys like that one. Or diamond, or cross method, whatever. Everyone calls it something different here. Okay, so A times C would be -6 times +1. That's going to give you a -6. And then -1 in the middle. And then what multiplies to -6 and adds to -1? Well, yeah, 3 and 2. Is it 3 minus 2 or 2 minus 3? No, 2, +2, minus 3. All right, so then you're going to split the middle term into a +2y and a -3y. And you bring down the first term and the last term. Okay, and then we're going to factor by grouping. So I'm going to split this down the middle, and I am going to pull out a GCF. So -6y plus 2y would give me, I could pull out a, well, you could either pull out a 2y or a -2y. Let's do the negative. So -2y. That's going to give me, and I'm going to move this over here. So you're going to have a -2y, and then that's going to give me +3y, and then that's going to give me on this side -1. What can I pull out of here? Just 1. But I want to change the signs so that they equal what I have over here. So I'm going to pull out a -1. You could have pulled out a +2y and then +1 here. You're still going to get the same solutions either way. This will give me a +3y and a -1. So these two are the same. That's one factor, 3y minus 1. And my other factor is the -2y minus 1, these guys. Okay, and this is solving, so I'm going to set it equal to 0, and then I'm going to solve. So I have -2y minus 1 equals 0. I'm going to add 1 to both sides. I get -2y equals 1. Divide by -2. That gives me y equals -1/2. And then on this, pen go, there it is. Okay. Then I have 3y minus 1 equals 0. I'm going to add 1. 3y equals 1. Divide by 3. 3's cancel. Y equals 1/3. So I get two solutions. Y equals -1/2, +1/3. And you could do the quadratic formula for that if you want. You would just have to work it out completely until you got the 1/2 or the -1/2 and the +1/3. All right, the next one is a little tricky because you have fractional exponents, which you're not used to seeing. So let me just portion this off here a little bit. Okay, this is the same as that x to the 4th x squared. You're splitting that middle term, the 1/3. You're factoring. Okay, so let's go ahead and factor this. So we're not going to use the quadratic formula because It's not a quadratic. Okay, it's fractional exponents. We want a factor. So you're going to treat it like you would anything normal, factoring. You would have your x and your x, but you're splitting the middle term, so it's x to the 1/3, x to the 1/3. Just like we did the x squared and x squared in the problem that started with x to the 4th. Because when I multiply these, I'm going to end up adding them, and 1/3 plus 1/3 gives me 2/3. Okay, so I'm splitting that, and I'm going to do mistake method here. So I'm going to say 2 times -15 is -30. And then we want a factor that multiplies to -30 and adds to +7. So I'm going to list my factors. 3 and 10. 3 and 10 should work. So it's a +7. Yeah, so 10 minus 3. So I'm going to go plus 10 minus 3. And then it's the mistake method. So then I'm going to take the 2, put it underneath my factors, and then simplify. So I'm solving. Well, let's just go ahead. Okay, so 10 over 2 is going to give me 5. So it's going to be x to the 1/3 plus 5. This isn't going to simplify, so the 2 is going to come to the front here. So 2 x to the 1/3 minus 3. So those are my factors. So everything is the same except you just have that 1/3 there. Now when you solve, it does get a little bit different because you're going to have to get rid of the 1/3. So what you're going to do, take each factor, okay, it's solved, set it equal to 0. Okay, isolate the x, so I'm going to subtract 5. Any idea how to get rid of that 1/3? Yeah. But instead of multiplying it by 3, I'm going to raise it to 3. So if it were 1/3 x, you'd multiply it by 3, right? Well, it's the same thing. You're just going to raise it to the 3 over 1. So you raise it to the reciprocal power is what you're going to do there. And then you're going to do that on both sides. So these will cancel. You'll get x equals -5 to the 3rd, which is -125. I just want to show you. -5. Here's your raise button to the 3rd. -125. Okay, now we'll do that over here as well. So you have 2x to the 1/3 minus 3 equals 0. So here I would add 3 to both sides. You have a 2x to the 1/3 equals 3. Divide by 2. X to the 1/3 equals 3 over 2. Then raise it to the 3rd. So we take 3 over 2 and raise it to the 3rd. So you have two options for that one. You can do 3 cubed over 2 cubed. Do it by hand. 3 cubed is 27. 2 cubed is 8. So you get 27 over 8. You can put that in your calculator. Okay, 3 over 2 would need to go into parentheses. Fractions would need to go in parentheses. So 3 divided by 2, then raised to the 3rd power. It's going to give you 3.375. You can convert this to a fraction in this calculator. Hit the button that says math. That's convert to fraction. That's what the first one is. So enter, enter. Okay, so your calculator will convert your fractions for you, which will save you a lot of time. Two solutions, x equals -125 and 27 over 8. If you give the decimal answer, you might get marked wrong. On the test, if it's a short answer question, I'm not going to mark that wrong. as long as you're showing your work. All right, now these ones here, so this is what I was talking about. Anytime you have an equation that starts with a square root in it, you got to check. That's going to be a requirement. Okay, so let's write out the steps for this one. So the first thing you're going to do is you want to isolate the radical. Then you are going to square both sides. Then you're going to solve. And then you're going to check, and check is going to be a requirement. Whoa. So if it starts with a square root in the equation, the other one had a cube root. Yeah, so it starts with a square root. And my math app will tell you solve and check. It won't say that if it's not, so it'll just say solve. On the test, it'll say solve and check as well. But I know you guys don't read directions. So look at the equation. Do I need to solve this or check it? Yes. But I mean, when you're taking a test, you should be checking every question anyway. All right, so we will square both sides. So square root and square cancel each other out. You get 4x plus 44 equals x plus 8 squared. So x plus 8 times x plus 8. Now we have to work that out. So we're going to go x times x squared plus 8x plus 8x plus 64. That's going to give me an x squared plus 16x plus 64. I'm going to bring this down. Okay, now at this point I say, oh, I have an x squared, which means I have a quadratic. So when you have a quadratic, the first thing you want to do is set it equal to 0. Okay, so I'm going to take the 4x plus 44 and I'm going to move it over to the other side. So I'm going to subtract the 4x and the 44 from their like terms. So on this side, they'll cancel out and I'll get 0 equals x squared plus 12x plus 20. Then I want to solve. So can I factor this guy? Yeah, this is going to be x plus 10 and 2. 10 and 2. 10 times 2 is 20. 10 plus 2 is 12. Okay, then set them equal to 0 and solve. So you have x plus 10 equals 0. That's going to give you an x equals negative 10. X plus 2 equals 0 will give you negative 2. All right, so your answers are x equals negative 10 and negative 2. Now you have to check for an extraneous solution. Does anybody remember what an extraneous solution is? So an extraneous solution is when you plug it back in and it doesn't work. Okay, usually when you get the answer right, you plug it back in and it should give you a true statement. Extraneous is going to give you a false statement. So here's what we mean by that. Let's check the negative 10. I go square root of 4 times negative 10 plus 44 equals negative 10 plus 8. So 4 times negative 10 is negative 40. plus 44. That's going to give me square root of 4 equals negative 2. Is that true? Nope. No. Okay, so when you take the square root, so in these questions, I know technically plus or minus square root, right? But we're not doing, that's when you take the square root. So that's the difference here. You're not taking the square root, you're checking the answer here. So anytime you plug it back in these types of equations and it comes out to be a negative on the other side of the radical, you throw it out. Okay, when I plug negative 10 in, it gave me a false statement. So negative 10 is extraneous. Technically, yes, even though. Yes. So then I'm going to plug the negative 2 in. So that one should work. If they both don't work, what would my answer be? No solution. But you can kind of start to see it because this is going to be positive. It's going to be a positive 6. So if it's positive, it should be okay as long as the number over here is okay. So 4 times negative 2 is negative 8. Plus 44 is 36. So square root of 36 is positive 6. We're good to go there. So the only solution here is negative 2. So if you put negative 10 and 2, it's going to get marked wrong on the test. If you do that on your homework, if you do that on the test, you're going to get it marked wrong too, because then I know you didn't check. I'm not going to give you half credit for that. The only answer, it's negative 2. 6 is what we got when we plugged it back in. So the answer here is x equals negative 2. Okay, so now we have another fractional exponent problem. So the fractional exponent problem is going to be similar to the one where we factored with the fractional exponent, except I don't need a factor here. I'm just going to solve. You're going to isolate the x to the 11 over 2, and then you would just raise to the reciprocal. So let's look at that example here. Add 6 to both sides. That's going to give you 2x to the 11 over 2 equals 6. Divide by that 2 in front. So x to the 11 over 2 equals 3. Then you raise to the reciprocal power. So you're going to raise to the 2 over 11. I'm pretty sure you can leave it like that because this number is going to be crazy. So if you want to see what it is in here, let's see. You would go 3 and then use your caret. Now there's a fraction, so you need to put the fraction in parentheses. So parentheses 2 divided by 11. Yeah. And if I convert it to a fraction, it's not converting to a fraction. Why isn't it converting to a fraction? Because it's a really nasty fraction. So you could just leave it as 3 to the 2 over 11. So if it's not going to give you a nice easy fraction, like if it were 2/3, you could do that. Or not 2 to the 4th, that would be 1/2. But you get my drift. 2 to the 5th, 2/5 even, maybe something like that. But 3 to the 11th is a really big number, so you're not going to need to write that whole thing out. Kind of use your judgment on that. Now, if I said give an approximate answer, then you would do the decimal equivalent, because that's the approximate answer, 1.221. And it would say give the approximate answer to 3 decimal places or 2 decimal places. So it's indicating I want it in decimal form. So again, if you read the directions, you'll see how it needs to be answered. All right, number 9. I'm starting with a radical in the problem. I have to check this one. Okay, so start recognizing those. It starts with a radical in the problem, then I need to check. I'm sorry? Okay, so what I'm going to do here is I'm going to isolate my radical. Dividing by -4. That's going to give me the square root of x minus 2. Oh, I wrote -5 there because that's what you're going to get. That's a 4. Okay, that is going to give me -5. Let me fix that. All right, what do we recognize? What do we notice about that right off the bat? What's that? It's negative. There's a radical and it comes out negative. You could stop there. It's going to be no solution. Anything I plug in there is going to give me a negative number. Not going to work. But you can go through and you can solve it if you'd like, just to prove it. Okay, square both sides. That's going to give you x minus 2 equals -5 squared, 25. It's going to give you an x equals 27. Plug it back in. -4 times the square root of 27 minus 2 equals 20. 27 minus 2 is 25. -4 times the square root of 25, 5, does not equal 20. It equals -20. That's a false statement. This goes away. There's no other solution. No solution. All right, so you start recognizing these. Number 10, do I need to check that one? One below it? Yeah, it's got a radical. You got to check it. So we'll start by isolating the square root. Subtract 6 from both sides. That's going to give you 8 equals square root 12 minus x. There's a positive out there, so that gives me a good shot that I'm going to have a solution for this one. I will square both sides. 8 squared is going to give me 64 equals 12 minus x. All right, we'll go through, we'll subtract 12. 64 minus 12 is going to give me 52 equals -x. Take that negative, -1, divide by -1. I'm getting a -52 for my x. Let's go ahead and check it. So I get 14 equals, let's see, 6 plus 12 minus -52. So 12 minus -52 turns into 12 plus 52, which gives me 6 plus the square root of 64. Square root of 64 is 8. 6 plus 8 equals 14. It does. So I can keep this answer. All right, that's 1.6. So 1.6 is a very, very crucial part. I would say the hardest parts of this section are going to be 1.6 and 1.7. Or not 1.6. 1.6 and 1.5. 1.7 isn't that hard. So 1.5, the quadratics, and 1.6, if anything, you would need to concentrate on.